So I'll leave this up on the board here for a little bit. I want you to color code your notes to go along with this so that when I'm talking about bases and heights and all of those things, you can see what I'm talking about. So for the most part in these figures, I've been using red for base and blue for height. The base would be found in various ways, which will refer to our area formula chart. But I'll stop talking and leave this up here. I'll zoom in a little bit more so you guys can see it on the TV better. But let's go ahead and color code what we think would be helpful for us to use this as another formula chart. And like I said, don't forget, there is one super glaring, obvious to me, typo that I made. Oops. We'll highlight first and I'll fix my typo second because it's an easy fix. It's just I'm used the wrong formula. Oops. We'll fix it later. I'm going to scoot it down a little bit so we can color code a little bit more. Are we good if I just zoom all the way to like this? Are we okay with that? Okay, fabulous. I'll pause again. Let us color code. Say again. That is orange, yes. Okay, I'm hoping that's enough time for us to have color coded some things. Like I said, I do need to fix the typo on here. And maybe you would have noticed it as you went through it. We're going to the top of this page. For the pyramid, the formula for volume, which again, this is a reference page for you to look up the different volumes. What word am I thinking of? Period is a AP pre-cal term. The volume of a pyramid should be 1/3 base times height. Did I remember to put the 1/3 when I worked this problem? Oops, so can we fix it for me? That just means that what we're going to do is we're going to take these numbers that we have here and we're going to also multiply by 1/3 and multiply by 1/3 and multiply by 1/3, which means this final answer that I have boxed right here is not correct. But on your calculators right now, I want you to take this number that I wrote down and multiply it by 1/3 because that would actually be the correct answer here. So I'm going to undo this. And I know you just get to mark out. You don't have like a pen that can write in white to undo all of this. But when you take 528 meters cubed and divide it by 3 or multiply it by 1/3, what do you get? That should actually be the meters cubed. Say it one more time for me. 176 meters cubed. That was my bad. I forgot the 1/3, which is a classic mistake. And look, now you'll never make that mistake. If it says 1/3 in the formula, you need to make sure you're also multiplying by that 1/3. My bad. But if you look at each of these formulas for volume, it usually relies on the area of the base. That's what big B stands for. So we can refer back to the formula chart we have for area and find the area of these different bases. When it comes to the volume of a cylinder, again, it is the area of the base times the height. The area of the base is just a circle. So I've used this circle area formula, pi r squared times the height, h, for that cylinder. The cone is 1/3 of that, 1/3 times pi r squared times h, which is 1/3 base times height, because the base is a circle. We have our formula for volume and our formula for a hemisphere. Hemisphere is like half of a sphere, chopped right in half. That's the cross section. But what we're going to be doing today is not just volume, because we can plug things into formulas. If you flip it over, we're going to be working on the volume of composite figures. Now, composite volume is like taking, instead of like composite area, where you take two shapes, add them together, and they're 2D. These are 3D terms. So what we're going to do is take the 3D volume and add or subtract them together as needed. I'm going to have you do work kind of like we did on the area formula pages. So what I first want you to do when we're doing a composite figure is figure out what two shapes create the larger composite figure. What are the two shapes involved in this problem? A cone. So I'm going to say that the volume of the whole thing is going to be the volume of the cone and the volume of the cylinder. Fabulous. Now I know I'm going to flip my paper over and write down the formula for volume of cone and the formula for volume of a cylinder. So flip yours over. What is the volume of a cone? Very good. 1/3 pi r squared times h. And since you're still flipped over there, what is the volume of a cylinder formula? Fabulous. Pi r squared h. Now these h's are not going to be the same letter, so technically I should call them h1 and h2, but I think we're going to be fine in just figuring this out ourselves. So let's figure out what each thing is when we're filling it in. The 1/3 drops down, and I'm going to drop down the pi, but I need to put a number in for radius, and I need to put a number in for height. For the cone, what is the radius of the cone? 3. Very good. So I see that we're looking at this radius right here, and that the radius is 3. Now this is a challenge question. What is the height of that cone?
5.
Ooh, is 5 the height? Like when you measure how high you are, do you like lean sideways against a wall and say that's how high I am?
6.
You like stand up tall, right? Do we have a number on the height for the cone? No, so we are going to have to find the height of the cone. So we're going to sneak off to the side here. It's a little side project. We're going to find the height of the cone. To find the height of the cone, I notice that I have this triangle created with a 3 and a 5 right here. When we studied triangles, right triangles in particular, we learned about a theorem. It should be your favorite theorem, maybe a theorem you can say. What theorem did we learn about? Pythagorean theorem. We're going to use Pythagorean theorem to find the missing side of this cone. So the height of the cone is going to be the square root of the sides. So we'll call it the radius squared. I'm sorry, that's wrong. The side length squared minus the radius squared. So the tilted side length minus the radius. The tilted side length we see, or what you could call your hypotenuse, is 5, and my radius is 3. Can y'all throw that into a calculator for me, please? What is the height of this triangle? 4. So square root of 5 squared minus 3 squared is 4. So I can go ahead and put that number 4 in my parentheses here for the height of the cone. And because I'm a good mathematician, I'm also going to label my picture. So we had to go on a little bit of a side quest there to find the height. Sometimes it will be given to you, but usually we would just need Pythagorean theorem to do that. To do the cylinder, I'm going to bring down the pi, but I need a radius again, and then I need the height of the cylinder. Well, the radius of the cone and the radius of the cylinder, since they match up, is going to be the same, so that's 3. What is the height of the cone, though? What is the height of the cylinder? 6. That's where we put the 6. Now, when I had you guys do the area problem, I wanted you to do it piece by piece, and I want the same thing here. So can we please put in our calculator 1/3 times pi times 3 squared times 4. Stop at the plus sign so we can get a number for the volume of the cone. We'll round to the nearest tenth, so give me 1 decimal. What did you guys get? I see you're still typing. Sorry, I went faster than you. Did we get 37.7? Yes? Then we go to the next part, the volume of the cylinder. Type in your calculator, pi times 3 squared times 6. What did you guys get there? Did you get 169.6?
No.
Fabulous. To get the area of the composite figure, so we found volume. We found the volume of the cone. We found the volume of the cylinder. Since they're stacked on top of each other to create one giant shape, we're going to add those numbers together. 37.7 plus 169.6 is 207.3. But remember, if you answer just like this, it's wrong. Back to when we did area, what did I make you put at the end of every problem? The units, what are we measuring in? And since this is volume, it's a three-dimensional measurement. We're going to cube centimeters. So 207.3 centimeters cubed. Not squared, that's area, 2 dimensions. 3 dimensions is cubed. If we look at the second problem, what sort of shape is happening here? It's a cylinder and a rectangle. Is the rectangle added onto the cylinder? It's like taken away, right? So instead of adding these together, what am I going to do with the two volumes? Subtract them. So if we were setting this problem up, we would say the total volume is equal to the volume of the cylinder minus the volume of the rectangle. I hear the flipping, which means we're looking for those formulas there. The volume of a cylinder, we did just do this one, is pi r squared times h. What is the volume of a rectangle? Say again? Not a square, a rectangle. Or a prism. It's using the word prism on your base times height. So we have to take big B times little h height. Okay, I wrote it like this, but I actually want us to alternatively, instead of using big B, think about what the base of the shape is. What is the base of this prism? Well, what shape? Let me rephrase. What shape is the base? Not a square, a rectangle. When you're finding the area of a rectangle, what do you do? Yeah, also known as length times width, right? So instead of writing big B times h, which is the formula you have on your paper, let's actually write big B as length times width. That way we can do length times width times height. That is base times height. The base is just a rectangle, which is length times width, or base times height, little b times height. Okay, let's see if we can fill in all of our information here. We dropped the pi down, and then I need a radius. What is the radius for this shape? 6. Very good. We can see that that is the radius, so I'm going to put radius there. And then I want the height. Remember, this is specifically the height of the cylinder. 12. Awesome. And then I have 3 dimensions to get here, because I'm going to subtract the length and the width and the height. So for that rectangle, what is the length? The base, sorry. So look at the shape that's cut out, not the longest part. 4, okay. 4 is my length. Oops. 4. What is the width? 3, heard it. And then if we're talking about the height of the rectangle, what is the height of the rectangle? My friends, if this is 12, how much is this? 12. So the height of my rectangle is also 12. Once you get the numbers plugged in for the volume of a cylinder and the volume of the rectangle, remember volume of rectangle was base times height. The base is just a rectangle, so length times width times the height. We can throw that in a calculator. Go ahead and do the first part. Pi times 6 squared times 12. I want that number first. Go for it. Pi times 6 squared times 12. We should get 1,357.2. But we're going to take out that piece in the middle that's missing, which is 4 times 3 times 12. The volume of that rectangle. Is that what you guys got when you did it? So to finish up the volume of my composite figure, the total volume, I do 1,357.2 minus 144. And I would get 1,213.2 what? What do I put after this? What does M stand for? Do we know?
Meters.
Meters.
Squared.
Not squared. Cubed. Volume is cubed. Area is squared. Volume is cubed because it's three-dimensional. So we have the volume to be 1,213.2 meters cubed. So it models after how we did the composite area, which we were pretty good at. Composite volume is the same. But we have to figure out what the shapes are first. Talk to me about number 3. What shapes do we see here? A pyramid. And what else? Rectangular prism. Yeah, a prism or a rectangle. Cool, cool, cool. Are they added together?
Subtracted.
Which one's bigger?
The prism.
The prism. So we're going to take the prism's volume and we're going to take out the pyramid volume. So if I was setting this up for myself, I would say the total volume is the volume of that rectangle minus the volume of the pyramid. All right, I heard the flipping, which means y'all are on the right track. Volume of a rectangle is big base times height. But remember, let's be more accurate with ourselves here. This big B stands for the base. What is the base of this prism? Isn't it also, it's a rectangle?
Yeah.
Okay, so the base of my rectangular prism is a rectangle. What's the area of a rectangle? Say again? What's the area of a rectangle formula? We just did it. Length times width. So we're going to do length times width times height. Let me scoot that over. I can't fit all those letters. Length times width times height. That is big B base times height. The base is a rectangle. What about the pyramid? What does it say on your formula chart for volume of a pyramid? 1/3 base times height. Okay, but that big B stands for the base. What is the base of this pyramid? What is that called? It has 3 sides at the bottom?
Oh, it's a bottom.
Yeah, the base. 4 sides, which means it's a rectangle. So again, we can change this formula from big B times H to the rectangle formula, length times width times height. So the big B represents the base area. I find it easier to put the formula for the base area in my problem. Then we can look at the question itself to find all of these things. Okay, first up we wanted the length of the base. What is the length of that rectangle base?
12.
Do you mean 21?
Yeah.
Yeah, I see it. Yeah, 21. No, you're good, you're good, you're good. So I'm going to put the number 21 right here. What is the width? 7. Fabulous. So I'm going to put 21 and then times 7. And then we need the height. What is the height? 15. Very good. So I have this 15 right here. That will end up being the volume of my rectangle, length times width times height, or big B times H. But I'm going to take out that pyramid, which means I'm going to subtract away 1/3 of the length times width times height of the pyramid. Looking at the pyramid, what is the length of the pyramid? So it should be the same base, right? We're looking at the base of the pyramid. It is still 21. Yeah, they share the same base, so they're going to have the same values here. What is the width? 7 again. And what is the height for my pyramid? 15. Now this ends up being the same value. I'm going to highlight it separate just because you see that it is actually the same height here of the rectangle and my pyramid. But we have all our numbers. Now it's a calculator problem. In your calculator, please do 21 times 7 times 15. Did you get 2,205? Fabulous. Now that's the volume of the rectangle, but we're going to subtract away 1/3 times 21 times 7 times 15, which means we're going to subtract away 735. 2205 minus 735 means that we get 1,470 what? Inches cubed. Very good. So we were really good at composite area. Composite volume is the same idea. You figure out what shapes you have in your composite figure. You get their volume formulas, however it takes to find their volume, and you either add or subtract them together to create your composite shape. Sound good? Now, speaking of composite shapes, we do have a project we started working on last time, which is our composite area project. And I'm going to give you some class time to continue working on that. I'm going to go back through all of the slides that I did last class so that if you were not here, you can get the full vibe of what this project is. And if you were here, you already probably know where you're at, what you're working on. I passed back all the projects that got left here. So if I didn't pass one back to you, you kept it, or maybe you put it in your folder. But I passed back the ones that I had. Let me pull up those slides.